Imagine you're working on a project, and suddenly you come across a problem. In this case, the challenge was to modify a simulation involving a Markov chain error. The goal was to add new patients at the start of each iteration while removing existing patients in state 4 from the simulation. Quite a tricky situation, right? Turning to the solution provided, the first step was to adjust the transition matrix and set up the parameters for the simulation. It involved creating a function to run the simulation, adding new patients, and ensuring that patients in state 4 would transition to a dummy state. This way, the simulation could accurately reflect the entry and exit of patients in hospital. Continuing with the solution, the key part was the simulation function. It handled the addition of new patients, the transition between states, and the calculation of percentages for each state. Filtering out the new and discharged patients helped maintain the accuracy of the simulation results. Moving forward, running the simulations across multiple iterations was crucial to gather meaningful data. The process looped through each simulation, handling new patient admissions, transitions, and tracking progress along the way. Monitoring the progress of each simulation ensured a robust analysis of the hospital scenario. Additionally, calculating average percentages and confidence intervals helped summarize the simulation results effectively. Using visualization techniques like ggplot, the data was presented in a clear and insightful manner, making it easier to interpret the trends over time. To enhance the understanding visually, an updated diagram was provided, illustrating the concept of patients moving through different states within the hospital. By incorporating new patients and discharged patients, the simulation became more dynamic and reflected real-world scenarios with accuracy. In summary, tackling the problem of modifying a Markov chain simulation to include new patient admissions and discharges required strategic adjustments and careful execution. By following the outlined steps and implementing the necessary changes, the simulation could better mirror the dynamics of a hospital environment. Good luck with your simulations, and remember, every patient deserves a smooth journey through the healthcare system. Remember, if you found this video helpful, don't forget to subscribe, like, and share your thoughts in the comment section below. Who knows, you might just uncover more interesting insights along the way. Happy simulating!